Sure.
Okay, I'm gonna go through one with you. There's one, remember was it Friday? Last Friday we didn't get through this one? I think so.
We've got 6 minutes.
That's all it'll take, no big
Okay.
deal.
Just start.
Okay, real quick, so what about this? We got a compound machine on a bicycle. The pedals have a length of that, 189.9 millimeters. The front sprocket, the gear attached to the pedals, has a radius of 49.9 millimeters. The rear sprocket, they tell us those dimensions too, the rear sprocket and the rear wheel. Assuming the bike is 96.2% efficient, applying 298 newtons of force to the pedals results in how many newtons of force being applied to the ground. Okay? So this is just going to be a case where we could do actual mechanical advantage divided by ideal or theoretical mechanical advantage equals 0.962, right? Okay, so how are we going to get the ideal mechanical advantage? So if there are two separate machines involved in this, there's two simple machines being joined in a compound machine, then the IMA is just going to equal the ideal mechanical advantage of the first machine times the ideal mechanical advantage of the second machine, right? So the first machine is a wheel and axle. On a wheel and axle, the wheel is the part that you're applying the force to, and the axle is the part that's applying the force to the load, right? So in this case, the pedals are the wheel, right? They're moving in a circle, and that represents the wheel. So IMA 1 equals the radius of the wheel divided by the radius of the axle, which is 189.5 millimeters over 49.9 millimeters. Do I need to convert the units?
Yes.
No, because they're the same units. I could, but I'm gonna get the same answer, right? So they're gonna cancel. Okay, so then that's IMA 1. IMA 2. For part 2, think what's going on there. The chain is what's being driven by machine number 1, right? So that's the input force. So it's the radius of the sprocket is going to be, or the gear is going to be the wheel radius. The axle radius is actually the wheel itself, right? Because you're applying force to turn the gear, and then the wheel is what's pushing on the ground, right? So that one's going to be 30.3 millimeters divided by 314.25 millimeters, right? So this first one has a large theoretical mechanical advantage. The next one has a really small one, right? Less than 1. If I want to find the overall combined mechanical advantage, it's just going to be that times that, right? Okay, so the theoretical mechanical advantage is just output force over input force, right? Input force is what we're applying to the pedals. Output force is what's being applied to the ground. That's what we're looking for. And so then we just end up with efficiency equals IMA over AMA. Right? This is stuff that we know, right? So that equals IMA divided by output force over input force. And in that equation, what's the only thing that's unknown? Output force. Yeah. So the only thing we're looking for is that guy. And so everything else, I can just isolate that, right? And solve for it in terms of those numbers that I have. right? Because efficiency is just gonna be 0.962. IMA is whatever that is, right? Right? First wheel and axle, mechanical advantage times the theoretical mechanical advantage of the second, right? So you got it.